So let's talk a little bit about how bonds are formed, and in this video I want to talk specifically about ionic bonds. In general, atoms are going to either donate electrons, accept electrons, or share electrons in such a way that they achieve a noble gas configuration. So you may recall in an earlier video I told you that noble gases are particularly stable, and all of these elements want to be like a noble gas. So that's kind of the rule of chemistry. Everybody wants to get to be as stable as they can be. So I've listed here the electronic configurations of the first three noble gases. So this is in group 8 of the periodic table, the very rightmost column. And you can see the 1s2, right, is helium. It has a filled shell. Neon starts with helium. And then we have the 2s2, 2p6. So we have 8 electrons in this valence shell. Argon starts with a configuration of neon, and then we have a 3s2, 3p6. So again, 8 electrons in the valence shell. So these atoms are either going to donate, accept, or share electrons in such a way that they get to be like a noble gas in terms of their electronic configuration, and whether they donate, accept, or share is going to depend on where they're located in the periodic table. So if we go back to our periodic table and we consider these guys over here on the right side of the periodic table, so in group 7, this would be the halogens. The easiest way for the halogens to obtain a noble gas configuration would be to gain a single electron. So if fluorine gained 1 electron, it would have the electronic configuration of neon. If chlorine gained 1 electron, it could have the electronic configuration of argon. So these guys over here on the right are going to tend to accept electrons. On the other hand, these guys over here on the left side of the periodic table are going to want to donate electrons. So for instance, if we consider the electronic configuration for lithium, its configuration is 1s2, 2s1. So 2 electrons in the 1s orbital, 1 electron in the 2s orbital. If lithium were to lose this 1 electron here in the 2s orbital, its configuration would be 1s2, or in other words, it would have the configuration of helium. So these guys over here on the left side of the periodic table are going to tend to donate electrons. So let's look at a couple of examples again. Lithium, and this would be a representation of lithium with the single electron in its valence shell, right? It has the 1s2, 2s1 configuration, or you could call it helium 2s1. The only electrons for bonding that matter are the electrons in the valence shell. That's why we only draw 1 here. And if it lost that 1, we'd have a lithium ion with a positive charge plus an electron. Same thing for sodium, which is right under lithium in the periodic table. Now fluorine, on the other hand, which has 7 electrons in its valence shell, and I'm just showing that with 7 dots. I'm not representing at all what orbitals those electrons are in. Nonetheless, if it gained an electron, I would have a fluoride anion, but fluoride would now have 8 electrons in its valence shell. And fluoride would be happy and can pretend he's a noble gas. Same thing with chlorine, which is right underneath fluorine in the periodic table. Gains 1 electron, has 8 electrons in its valence shell, now can pretend he's a noble gas. Now, these ions that are formed, say when a sodium gives up an electron to a chlorine, you have sodium plus and Cl minus, they are attracted to each other through the electrostatic attraction between positive and minus charge, okay? And they assemble together in what we call a crystal lattice. Now, there's not a specific bond between any one chlorine or any sodium. So in other words, this chlorine doesn't belong to that sodium, and it doesn't belong necessarily to that sodium either, right? And it's fairly easy to break up these interactions with very polar solvents like water. So sodium chloride is table salt, right? You can put it in water and it will dissolve because the water is very polar and it can break up those interactions between the positive and the negative ions. Same thing with hydrogen. So hydrogen atom has one electron in its valence shell. It can give up that one electron and just become a proton, H plus, with no electrons. That's also particularly stable. Or a hydrogen atom can gain an electron, and now that hydrogen atom has 2 electrons in its valence shell. We call that a hydride, but now it's stable because its outer shell is filled.